All right. Well, thank you very much for turning up for the last session of the day. I know it's not easy to sit through all of these sessions. So today I'll be giving you a bit more of a detailed overview about how we use drones in live events. If you didn't catch the first presentation, my name is Katie and I work at Verity Studios, the head of marketing at Verity. And so to start off with, I'll give you a brief history of the basically drones in live events throughout time and how we also use them, and then give you a bit of insight as well as to how we're planning to develop the technology in the future. So first off, a bit of context. So this here is our founder and CEO, Rafael D'Andrea. He's actually not your typical live events guy, and I think that really sets a scene for our company as a whole. You know, we really come from a foundation in robotics and AI rather than kind of system integrator live events company. And so he's actually a professor at ETH University, which is the leading technical university in Zurich. And his first venture was actually with Kiwi systems. So this is a robotics company that worked in warehousing industry, basically. So what the idea was is that instead of people going to a shelf and picking products off the shelves, which is very slow and time-consuming, the shelf would be picked up and it would be brought to the person. And the person would then pick the goods off the shelf and pack them into a box. So this made the whole picking process much more efficient. But not only were these vehicles autonomous, the system was also intelligent. So this here is a simulation that shows you how the warehouses were set up. So you can notice that there are some color gradients there. So in the center, it's cooler colors, and towards the outside, it's warmer colors. And so the system would actually recognize which items on a shelf were more popular. And if it was more popular, it would bring it closer to the outside of the shelving system. And if they were slower moving items, they'd bring them closer to the center. So it actually optimized the entire warehouses as it went. So I think it's really important to give you that context, because this is the kind of same direction we're going to with our drones as well, is not only making autonomous vehicles, but learning from their experience in live events and making them more intelligent as well. After a couple of years at Kiwi, Ruff decided to go and follow his first love, which is actually flying machines. So he actually founded a research lab in flying, called the Flying Machine Arena at ETH Zurich, and this is where our company was founded. And this gives you a bit of context of some of the things that they've actually been working on with autonomous vehicles. You can turn the audio up. So actually, many of our first employees have come from this research lab where they've been working with autonomous drone systems for the last 20 odd years in the history of their careers. So in 2011, I think it was, yes, this is when the first drones started being seen in kind of more artistic areas. And so they actually developed the very first drone choreography that was ever seen, called the Armageddon. Now, it was in 2011, so the quality is pretty bad. But you can already see how far we've come today. So just a short clip. So this was back in 2011, so 8 years later, we're doing a lot more with drones, but it's already impressive to see 5 drones kind of working in coordination in a fully autonomous fashion. And then we had our very first outdoor drone show that ever existed. So this was actually done by Ars Technica Future Lab, a product called Spaxels. And so long before Intel were doing their giant displays outdoors, these guys were really at the forefront of this technology and doing outdoor drone shows. Quite close to this, we actually founded our company, Verity Studios. Here are some people from the company here. And it was really a spin-off from ETH Zurich, that research lab. And the reason the company was actually founded were a couple of reasons. But one of them was that Ruff, our founder, had always wanted to fly a large number of drones in coordination with a rock band. It's a pretty lofty goal. But he had the seed money to start the company, so he decided to start Verity Studios to really pursue that goal. We did our first collaboration with autonomous vehicles in 2014. So actually, Cirque du Soleil had been seeing our work for some time. They worked specifically at the Flying Machine Arena, and they reached out to see whether or not we could do something to explore the creative potential of drones in a movie or in live events. And so we started with this short film called Sparked. So everything you see here is real. We did this in real time with the vehicles. They were all pre-programmed and then choreographed with the performer. But it's one of those funny things. Because there is so much CGI out there nowadays, probably thanks in some small degree to Weta Workshop, most people didn't actually believe this when it came out. And a lot of people were calling bluff and saying it was CGI. But everything we do isn't enhanced by computer graphics. It is really real. At around about the same time, a couple of months later, Intel and Ars Technica, who you saw before, actually created the first Guinness World Records for drone shows with 100 drones. And again, it's funny to look back at this now because you look at it and you're like, it's pretty crap. It's not that impressive, really. But then you see how far along they've come today, and it's amazing how quickly the technology has evolved in just a very short amount of time. And then, of course, Verity Studios, so up until 2016, the company was in stealth mode. There were a lot of developers working at the company and not really anyone else, and it was mainly to develop the technology, so it was at a state that it actually could be deployed in a live event setting. As you guys all know, it requires quite a mature product that can tour with a band, for example, and be stripped down and put back up again night after night. And so it took some time for us to get there from a technological standpoint. And then we launched, we did the first indoor drone light show that ever happened at TED 2016, where we had these little Firefly drones, and really it was to test the concept. And they flew over the audience at TED, and it's something that people had never seen before. Up until that point, we were really working with very large drones, but of course there are some logistical challenges when you have very, very big vehicles. And here you can see an example of these vehicles here. So they are 1 kilogram stage flyers, we call them. And they look very impressive, but they are quite intimidating. 1 kilogram is really quite heavy. And of course, from a logistical standpoint, if you have to have one person every time you want to place a single drone on the stage, it becomes a bit of a challenge. And so despite how beautiful this looked on Paramore on Broadway, which is the first permanent installation we did, again with Cirque du Soleil, we decided to kind of move towards the smaller vehicles, which you see in many of the drone light shows today. But because we did develop these large vehicles and we were deploying them night after night for almost 400 performances on Paramore on Broadway, what we had to do is develop safety technology. So if one of these motors failed or propellers failed, they wouldn't come crashing down onto a performer, because obviously that would be bad. This gives you kind of a brief example of what that could look like. Yeah, there are some actually hits people as well. I didn't really want to show you those graphic details today, but obviously that's a major concern. You've just had a safety presentation. I'm not sure if any of you were in it, but obviously there are safety considerations that need to be considered whenever you're deploying a new technology in live events. So what we actually did, we have some very talented engineers on our team, and so they actually developed a special technology called fail-safe, which means that a drone can fly on only 2 propellers. So it means if any of them have a failure, have a motor failure, propeller failure, it can continue to fly instead of just crashing out of the sky like that drone that I just showed you. And this is what it looks like. So you can see this guy, he's obviously a little bit apprehensive. He's in a hoodie and has safety goggles on with a big stick. He's going to kill one of these propellers so you can see what fail-safe looks like. So here you can see it takes a little bit of time to recover. It recovers in about 2 meters, but then it can spin itself to keep itself in the air and utilize the 2 propellers it has left and then land safely. This actually did happen to us once when we were working on Paramore on Broadway, and people just thought it was part of the show and no one was hurt, which is very good. But of course, for obvious reasons, we did move to these Lucy microdrones, and they're responsible for most of the shows that you see today. And this is just a short video that shows you some of the things that we've been doing. So since 2016, we've done 150,000 flights. If you were in the morning presentation, you know that that is the largest number of autonomous flights indoors that anyone has ever done, and we're really learning from this data set and improving our system more and more for live events. We've done around 2,000 shows now in more than 20 countries around the world. None yet in New Zealand or Australia, so if you guys can help with that, please let me know afterwards. We do typically 3 types of events, so one-off kind of corporate events. Most of them we can't really talk about because we're under NDA. Permanent installations, cruise ships, interestingly enough, a very big market for us. We're now installed on 4, soon to be 5 different cruise ships. And touring productions like Drake and Metallica as well. So how does it actually work? Right, getting into the nitty-gritty of it. So you can see here, this is kind of a semi-technical drawing and outline of how we set up the system. So usually we have to deploy our own indoor positioning system. So how many of you here actually have your own drone at home? A couple of you? Okay, so when you fly them outdoors, you're very lucky. You have the luxury of the GPS, Global Positioning System. What that basically does is tells the vehicle its position in space so it can localize itself, and then you can fly it on an either autonomous or manual flight path, and it understands where it is in space, so it can be very stable. Indoors, unfortunately, it's a GPS-denied environment. You don't have access to GPS here, and so what we've had to do is actually create our own GPS. So we've used the same architecture that they used to create a GPS, and we developed our own indoor positioning system. So how that works is these kedges here, they act as satellites in the space. So here you can see them on the top, the red boxes, and you can also see them on the bottom as well. So they're placed around the space, and through the network created by these satellites, the drones can receive their position data, and then when we choreograph or we upload a pre-programmed choreography, they can follow that flight path autonomously, and they don't have to communicate back with the system or with each other because they alone know where they are in space. You'll also see that we have, again, we're very, very conscious of safety in our practices, and so we have redundancies set up as well. And so if any one of these units fail, the whole system can stay intact. So we have redundancies in our processes and also in the units. Now the other parts of the system, obviously the star of the show is the Lucy micro drone. That's this one here. So as you can see, it's tiny. It weighs only 50 grams. It actually is about the same size as my hand. And someone was asking about the propellers before, so obviously it doesn't have flexible propellers, unfortunately, but they're about the same size as my pinky finger, so it really doesn't make that much of a difference. I can stick my finger in there and I'm no worse for the wear. It does mean that if it falls on someone in a performance and a performer or so on, it's not going to cause any lasting damage, which obviously is very important. As you can see, it has a very bright RGB LED. It has actually 140 lumens on the white channel, but of course it's not going to compare to an actual fixture. And here, yeah, you can just put your finger in and you can see it doesn't really harm you. So you're welcome to have a look. She did get a little bit broken on the way, unfortunately, so please be careful of that. But feel free to pass it around. The light will turn off in just a second though. But of course, I mean, that's just a vehicle at the end of the day. Like a fixture is just a fixture. It really means nothing until you can actually do something creative with it. So who we also have on staff are our drone choreographers, and they're really an integral part of our company. And so they are actually engineers. They're not typical live events people either. Every choreography that we do at the moment has to be coded in C++. So it's not accessible for everyone. It is something that we hope to change in the future. So what they will do is they'll work with our client, the creative team, try to understand the concept and the piece of music, and then they'll develop the choreography in C++ and pre-visit in Blender, so they can then see it before they go in site and make any creative changes that they want. So this is actually a previs of a show that we recently installed on a cruise ship, and I'll show you the final version of that later on. How they all travel, so as you can see by this poor little damaged creature, got hurt on the way, they're quite fragile. They're very light and fragile. And so we have to keep them safe through transport, and obviously while they're on site, charge them and download the data from them as well. So what we've actually developed is a charging station, which is a standard flight case that we've retrofitted with drawers and charging capabilities. So when you deploy a show, you can pick up a tray directly from the charging station, place it on the ground, put it back, put some foam inlays in there, and then lock it up and it's ready to go on tour as well. This just takes you through a little bit more of the system. So when we develop a choreography, we create something called roles. And this is basically the parts in a play that each drone is going to play in the choreography. The nice thing is you can chop and change the roles. It's not as easy, obviously, with a real performer, but with the drones, you can simply take the choreography off the drone and then re-upload it. So how you do that is here you have all of the vehicles. They have to be docked in the charging station at the time. And then here you have the different roles. So this includes the code for each of the flight parts in the choreography. You simply drag and drop the vehicle into the role. It will then upload to the vehicle, and it will know how to play its part. It'd be nice if it was that easy for everything. And here you always have the status of the drones as well. So here you can see a lot of the slots aren't filled. You can fit 40 drones in each of the charging stations. But you can see the status of each of the drones if there are any areas that you need to check before you deploy them as well. When you are ready to deploy them on stage, this was actually at Starlight Express in Bochum. So we're part of their Starlight sequence. The whole production has been revitalized. So when you're ready to deploy the drones, you could just simply take out the charging tray straight out of the charging station. It fits 8 drones to a tray, so it's much easier than the large stage flyers. We have to do it individually one by one. You place them on the stage and they take off immediately from there. Then at the end of the production, you pick them up, put them back on the tray and back into the charging station where they need to charge for an hour before they're ready to go for the next time. And then when it comes to actually starting the show, it's very easy. It's actually not that hard as well. It sounds more complex than it is in reality. We actually had a guy who was in his 70s. He was the operator for one of our shows in Switzerland. And so, I mean, it is something that everyone can learn. And that is this. I mean, all you need to do really when you're ready to start the show is arm the drones. Which sounds scary. It's not. Press play. They fly. They do their choreography, and then they'll land back down. And if at any point you're concerned about the way that the choreography is going, or if someone from the audience has managed to get up on the stage or done something silly, you can soft stop the show, which looks something like this. So they'll twinkle their little lights and they'll do a controlled landing down. Of course, there's always the e-stop option as well, but there you're going to break a few vehicles and it's probably not the best call. So we always make sure there are safety measures in place so that you can deploy these vehicles in a safe way, because drones are very, very new in entertainment now, and we do understand that if there are any serious incidents with our vehicles or with anyone else's, that can really put a stop to the innovation that this type of technology is creating in the market as well. So what that means is really the drones are safe to fly over performers on the stage like they did in the Drake tour. This was actually filmed at his Manchester show, I believe. But they also are safe in some circumstances to fly over an audience. This is something we are quite conservative about as a company. We don't like to just fly over any audience. We have to be really confident in the technology, obviously, but also in the operator, that they have created all of the necessary safety protocols on their side to make sure everything is good to go. But when we do get to fly over the audience, it's pretty spectacular. So that's actually seeing it come to life from the pre-visualization that you saw before. But we're also really excited exploring what else you can do with these vehicles, not just being a flying light, but just a way of actually transporting stuff around a stage. So you can imagine it becoming a flying prop or scenery or even a character in its own right, which is something we're really excited about. And so we have, as you all know by now, a drone costume designer, which is very exciting. And one of the things that she has been working on is obviously how to costume a drone. There are a lot of constraints around that, more than you'd expect. As you can see, it's so tiny, it can only carry a maximum weight of 5 grams. So every costume that we develop has to be under 5 grams. But then there are the aerodynamic properties of a costume as well. It can't create too much inertia, so the drone can't fly anymore. And so she has a lot of constraints to work around, but in doing that, she comes up with some amazing designs. So these are some of the ones that we deployed at London Design Festival. We're sponsored by Pro Helvetia to be there. And here you can see how it drastically changes not only the optics of the drone, but the volume of which it can take up in space. And with such a small vehicle, that's also really important. Because if you have a reasonably small space and you can't fly too many and you want to create a more impressive effect, costumes are really the way to go. And this shows you what this kind of looks like. So this is an underwater scene that we did in London using UV lights so that the costumes that you can see here really pop. The other thing with costumes is that if you're in a show and you're deploying a large number of these vehicles, you want them to be easy to dress. You don't want to have to spend a lot of time each time dressing your costumes. And so she has the additional challenge of trying to make it modular. For example, if you have something attached in the bottom, you can't just place it directly in the charging tray because then the contacts don't line up. And so she's created these little removable magnetic parts that you can simply take off and clip back on for easy deployment as well. And you're also welcome to have a look. But not only that, we have many, many requests for the Paramour costumes. When we had the really large drones that were great from an optical standpoint, obviously not from a logistical one, so we get a lot of requests. And so we've tried to recreate the same kind of look and feel with our smaller drones as well. So this is something that we put together actually for Chinese Central Television. They were interested, they were absolutely dead set on having the Paramour costumes. So we created a short video to show them what it would look like. And here I think in this more than any other video, because you have a person in there as well, you can see how much larger the drones look when they do have this kind of reflective material on them in the space. But that wasn't what they wanted in the end, so instead we developed a Chinese lantern costume for them. And this is what was actually deployed in the Chinese Central Television Spring Gala, which happened in February this year. This is the first large-scale costume drone show that's ever happened. And it was 88 of these costume drones, so you can imagine how time-consuming that was, with 70 dancers on a stage and 2 famous singers. But, you know, we're always looking at ways of how we can use this technology for new things. You know, we have people coming up to us all the time with ideas. I think that's one of the great things about this technology is it sparks a lot of ideas for different people. And so the one question we always get is, okay, great, you've got drones. Now we can have flying follow spots. You can have a drone that just follows a performer around on the stage, no matter where you go. So, you know, we tried it. But of course, it's a very small drone. And at 140 lumens, it's a pretty bright LED, but it's not going to be as bright as a follow spot ever. And so it's something that we're looking at of how we can create really what we call the mini spots. And so they can be used as a feature to kind of highlight a specific object on a stage, but it will never be able to light up a whole performer. And so if we're going to explore this future, then we'd look at creating a larger drone that can actually hold a much, much brighter LED or other light to highlight a performer on the stage. But I don't know. I'm not sure I'd be convinced about having a drone follow me around wherever I go on stage. I think that would be quite annoying, if I'm honest. We're also looking at ways of using fiber optics, obviously to increase the volume of the drone. There are some very, very lightweight fiber optics that are being created currently, and so I think as this technology progresses, it's going to be really interesting. With that as well, I mean, you saw the jellyfish tail. Imagine that with fiber optic fibers. I think that would look really amazing, and this is something that we're definitely working on in the future. But I think there's also this shift towards, you know, pixel mapping. As much as we like to say our drones are like individual pixels in space, I mean, they're not. They don't fly that close together. They need to have a safe distance because they aren't aware of each other in this space. And so what we're trying to do in the future is decrease the distance that the drones fly between each other, so we can create these really detailed shapes that you see up on the screen. So this is an example of what you could achieve with 50 drones, for example, this kind of very, very basic shape. 100, we're getting more detail, getting more contours there, and then with 200, you can create something really impressive. What that also means is it kind of opens up an avenue for sponsorship. I know that's not something we really like to hear, but the reality is that more and more consumers are willing to kind of trade off advertising for a really cool experience. And so by giving our clients the possibility of actually getting sponsors on board to pay for the expensive add-on of a drone show, this allows us a lot more opportunities to do cool events in the future. And this kind of shows you what that could look like in a hockey arena. So this in itself obviously poses some challenges. One, there are around 250 drones in that shot, so how do you deploy them all? And another thing, it's on a ice hockey field, and so often you're not allowed to place things on the ice, for example. The other thing is, the challenge is these sizes are huge, and so with our current localization system, you'd have to place a large number of these units, which obviously increases the cost as well. So there are a number of challenges for us in kind of realizing this vision, but we do recognize that the future is really to bring what's possible today with outdoor drone shows inside and give people that same immersive experience, because they'll be much closer to the vehicles as well. So, with that, I'd just like to open up the floor to questions that you have. I already had quite a few questions at the beginning, so I think I wanted to leave enough time for us to really kind of hash things out from a technical standpoint.
Because these rely on various transmitters and that, How do you stop them interfering with, say, wireless mics, and how do you stop the wireless mics interfering with the control system?
Yeah, that's a really good point, because we do use radio, so our localization system is based on radio. So what we do whenever we go into a venue is we ask the venue technical manager for a full list of all the radio frequencies they use. Quite often they do have to stock a list, not just for us, but for the other suppliers they're using as well. But then we also use many different frequencies on a wide spectrum of radio, and so we can pick and choose those types of frequencies that we want, so we don't interfere with any of the existing systems as well. Good question.
How susceptible are they to wind?
Very. Incredibly. So bad. Actually, even very, very strong air conditioning can cause them to struggle. They're incredibly lightweight vehicles. We had massive problems at LDI last year, actually, because when we were loading in, they had the loading dock open directly behind us, and no one really thought about that. And so we couldn't fly the drones to calibrate them or to do a rehearsal until everyone else had finished loading in the entire event. So this is a really big problem for us, and it's the reason that we only do indoor shows or outdoor shows if it's in a weather and wind protected area, like a big marquee. We actually did that in Abu Dhabi in 2017, and that worked fine.
How long can they fly for?
They fly for 3 minutes, then they need to charge for an hour. There's always a trade-off between the size of the battery and the amount of flight time they can have, right? And we want them to be very light and safe, and so we have a very small battery. But when we actually fly with Metallica there, depending on the guitar solo, it can take quite a long time to finish with the song, and so there we stagger the takeoff of the drones. And so if you have enough drones, you can actually fly them for an unlimited amount of time. It's just each individual one has to go back to charge after 3 minutes.
Would it be possible for a performer to launch one from their hand? So I'm just thinking, if it was used as a prop, could they launch that themselves?
Yeah, we have a lot of people who do this. They love that effect because it's really interactive. So the very first drone show we did at TED was actually with our CEO and having the drone launch off from his hand, and since then we've had quite a few people do it. We even have an ice skater on a cruise ship who she actually has this really beautiful dance with a single drone, so they have kind of a joint choreography together, and then she also interacts with it. It lands on her hands as well. It's actually a beautiful effect.
So how many drones can be launched in one go before the system gets overloaded, or what's the maximum you can?
Yeah, we don't have a maximum actually. We can deploy any number of drones. It depends on the size of the space. Actually, the biggest restriction is the size of the space, because we have to have a certain distance between each vehicle. And so if you have a reasonably small space like this, or if, say, we're doing a performance over the stage, if you pack too many drones in there, you can't do anything creative. All you can do is kind of move up and down. And so for us, we think that for smaller spaces, 32 drones is a really good number to do choreographies with. And the largest show that we've done so far has been with Metallica, with 100 drones up in the air at any one time. But as soon as we can get into these kind of hockey arenas or covered stadiums going forward, then we can do a lot more interesting stuff as well. Yeah.
Are there any plans for drones that are self-aware of like where the other drones are, or is that something that's coming?
Yeah, that's something that we're quite excited about and interested in for sure, because that would also enable real-time interaction. So we have a demo choreography at the moment where the drones open up and someone can walk through. And at the moment, it's all rehearsed. It looks like it's real-time interaction, but it's not. And that would be really cool to be able to implement, that you could really have an interaction with the drones. The reality is that from a safety standpoint, it's not great, because that gives you a lot of wildcards. Whereas if everything is pre-programmed, then you know exactly where everything's going to be at one time. You don't have to worry about any of those spontaneous errors that can occur. So while it's something that actually our founder and CEO, he works with a lot in his lab, like he actually plays ping pong with a drone, and there it's learning every time exactly where it needs to be in space to return the ball to him. So this is really cool to watch, but in reality, until the technology progresses and also people become more familiar and comfortable with drone technology, I don't think we'll be implementing real-time interaction anytime soon.
You mentioned this morning as a company was sort of leading the way in terms of legislation around drones and people. Do you know what sort of applications would be in New Zealand with that? Or
it's really interesting. I don't have a very good awareness of the regulatory framework in New Zealand for drones. But I do know that in Europe, for example, just a couple of days ago, they've released a new regulation for drones where all vehicles over a certain weight, and I think it's around 250 grams, have to be redundant to a mechanical failure. So that means exactly what I showed you before, that if they have a propeller fail or a motor fails, that they can keep themselves up in the air. So that's really positive for us, because that means that people are starting to focus more on drone safety. And we have one technology for stopping that catastrophe from occurring with fail-safe, but there are also parachutes and things that you can do as well. So I'm not sure if New Zealand is kind of following on from this European legislation or what the process is, but I think that more and more, particularly as drones progress and they become more commonly seen in the skies for delivery and so on, I think that's going to be really, really important. Because as soon as we reach a critical mass, I think these sorts of accidents are going to occur a lot more frequently.
If you are looking for legislation on drones in New Zealand, you just need to go onto the Civil Aviation Authority website. It's got most of the info on there. But most regional councils will have their own policy as well.
I think one important thing to note, though, is that with our drones, we fly indoors, and there no regulations apply. It comes down to the venue to approve it. So usually we have to get approval from the fire marshal and from the venue, and then we're good to go. And usually we don't have any issues with that because, for example, Changi Airport, we've done a show, and obviously airports are really firmly no drone areas. Also LDI, Madison Square Garden, also had no drone policies, and we're able to overcome all of those. So it generally doesn't tend to be a problem for us.
Noise. How much noise is from them?
Yeah, they do make a bit of noise. It's true. Luckily, they're very small, and that's one of the reasons why we have very, very small drones and tiny propellers as well, as they create a lot less noise. It is a concern that clients have when they come to us and they see the drones for the first time. Particularly if you're very close to them, you can hear them. It's true, it sounds a little bit like a fan. But the reality is, in most of the shows that we're in, there is loud music and the audience is quite far away from the drones. And even in a quiet scene, for example with Starlight Express, so the drones start flying in the Starlight sequence where Rusty is on stage and he's doing a solo. And even there, even though it's a very quiet scene, and that was a major concern from them, you couldn't hear anything. So yeah, it depends how close you are as to how loud they are.
Have you done any work with feeding back either direction with moving lights? So either have a drone stay within a light or feed the information back to the console so that it can follow the drone?
Yeah, it's a really good question. It's also something that we're looking into at this moment in time, because the reality is that if you can track a drone in space, you can track anything in space. And so we're not looking at necessarily moving lights following drones, but we are looking at kind of adapting our system so we can track performers in the space, similar to your Zactrax and Blacktrack and so on. The difference with their companies and ours is that we've developed all of this technology from the ground up, whereas they've actually integrated it from other systems. For example, Blacktrack uses OptiTrack, which is an optical tracking company, and Zactrack is using an industrial tracking company for their solution. And so this is something we're really interested in, and we'll be looking at developing something like that in the coming years. All right. Well, I mean, I'm going to be around. So if you have any burning questions that come up, please do come and say hello. I finish quite early, so you can thank me for that later.
Roughly, what is the cost of doing a show, like if you were to bring it to New Zealand and Australia?
That's a good question.
Field marketing manager.
Yeah. So it is expensive. Yeah, right. So it starts, it starts at around 100,000 US for a one-off event. Obviously, if you have a permanent installation, then you can kind of, spread that out over time. But of course, it is more expensive because you're doing more shows and so on, and there are consumable fees and that. So it is kind of a luxury item at this point in time. We are the only ones doing it as well. And that's why you can see, with the types of performances we do, it's really the top artists who have the money to pay for it at this point. But as the technology progresses and as more people come into the market, I'm sure prices will also come down over time. Just not right now.
With the likes of these touring shows, do you put your own technicians into tour with them, or do you train someone within that touring party?
Yeah, we actually don't need to operate it ourselves, and we prefer not to. We have kind of a small company, so our resources are limited. So usually we will go on site to install and commission the system, make sure it's all set up properly. Then we'll train a technician on site, and it can be anyone really, and they will operate it. So they will do the load-in every show, and they will operate it every show, and we don't need to be there, but we offer 24/7 support, so if they need a hand, they can have it.
With the choreography, it's like, say, one of these world tours, they go into different size venues and stuff.
Yeah.
So how do you allow the changes from venue to venue?
It's a big hassle. It's really a big hassle. With some of them, for example, when we were doing a load-in with Drake into Madison Square Garden, the truss height was significantly lower than all of the other venues because, of course, they have the big jumbotron that they can't go higher than that. And so we actually had to develop a new choreography for Madison Square Garden that was unique to that particular environment. But usually the changes are relatively small. So as long as it's not a massive change which significantly decreases the size of the flight space, and if we plan for the minimum flight space, then it's okay. You simply set up the units, so the kedges, and then you have to calibrate the drones. The good thing is that it's not like, I don't know if any of you guys have used a tracking system or autonomous system before, but for example, with some of the optical tracking systems, it's a hassle to calibrate. It's really time consuming. So a guy would have to walk around with a wand and kind of wave it around the stage with a wand, and no one can be in the space at the time and so on. So we understand that that's a real problem, particularly with touring shows, and so we have auto calibration. Basically what that means is you place the drones on the stage, they take off, and then they'll kind of bounce up and down, they'll see where they are in space, and they'll calibrate themselves, so you don't have to be involved in that process. The drones do it all on their own.
So do the drones always stay the same distance apart regardless of the transmitters? Or does the show scale with the distance apart the transmitters are?
No, they should always maintain the same distance. We have minimum distances, and I can't tell you what that is, but because we have some rules about what we're allowed to say and whatnot, but they do have to keep a certain distance apart, and that is for a safety reason. It's also because obviously the drones, they take in the air and they spit it out the bottom, and so if the drones fly too close together, it can cause a downdraft. And that's exactly like having the air conditioning up too high. It can cause our drones to struggle a little bit. And then they can't keep their position, in which case they'll do a soft stop. So basically they'll have a minimum distance for every single choreography. This will be pre-programmed, and it's independent of the space that they fly in.
Dampness affect them? Dampness, rain?
We haven't flown them in the rain. We have had a couple of people ask us to fly them in swimming pools, and we did have, for example, Changi Airport. That's always a bit dangerous. But Changi Airport, so they've actually got a new installation. I don't know if any of you have seen it, but they have this giant waterfall that comes down from the ceiling. And initially we were talking to them about flying drones around this waterfall. And we couldn't do it in the end. Actually, we could have waterproofed the drones, the components, quite easily. But what really caused the problem was, again, the downdraft of the water crashing down from the waterfall. It created a lot of airflow that our drones couldn't cope with. And so there are some other kind of weather type challenges that aren't necessarily to do with the rain.
there's no other questions, if you'd all like to join me in thanking Katie for today.